ABC is an isosceles triangle in which altitudes B, E, and CF are drawn to equal sides AC and AB respectively. Show that these altitudes are equal. Again, try to figure out what is that you need to prove, what is given. Okay, so that's the first step. So we have, for this question, you don't need to draw the diagram. We have been given that ABCD is an isosceles triangle in which B and C are drawn equal to sides BC and BD respectively. Okay, so we have BAB is equal to AC, right? So these are your two equal sides. Okay, two equal sides AC and AB respectively. It's given. So what else? We can conclude that angle ABC is equal to angle ACB, right? As opposite angles to equal sides of a triangle are equal. Okay, so again, try to write things like this so that your writing kind of reduces. It helps. So yes, we also have a no, not a BC, which is an altitude, PE, which is perpendicular to AC. This implies angle BEA is equal to 90 degree. Okay, because it's an altitude, it's given. And similarly, we have FC perpendicular to AB. This implies angle CFA is equal to 90 degree. Okay, so we just wrote that. So this is all the given part. And we have to prove that CF is equal to BE. Okay. Now the proof. So now you can pause and think over how to prove this. The basic structure, what is it? Right, we have, it's very simple, triangle ABE and ACF. If you prove that they're congruent, we are done. Okay, it's quite simple. If you're not able to figure out, a small diagram will help. So we have something like this and something like this. We have AEB and AFC. So remember, this is 90 and this is 90. A is common in both. Okay, we can, A is A, so we don't need to call it as anything. We have AB is equal to AC, right? And proving that angle ABE is equal to ACF is not that difficult. So why should we prove? You guys think over why we have to do that. So if we do this, we can tell that these two triangles are congruent. Okay. So now let's do this. In triangle ABE and I'm thinking of one more way. Wait, this is 90. These two angles are equal. Okay, 90. One more angle. Common side. No, it's the same length of writing. Nothing. We could have taken even triangle FBC and EBC, the small triangles at the bottom. Even that could have been taken, but I'm going with this as of now. Okay, so ABC. Okay, no, wait, maybe it's shorter. This is 90, this is equal, this is 90, this is equal. No, same amount of writing. Okay, In triangle ABE and AFC, we have AB that is equal to AC. This is given. Then we have angle A is common. Okay, we have a side, one angle. If we prove that other two set of angles are equal, then we are done. Then we have angle AEB, okay, which is equal to 90 degree. Actually, we will be doing this a bit later. Let me do this systematically so that you guys will understand how to go about writing as well. Again, if you are writing this way, it's not wrong, but now I know how it has to be structured, so it's clear in my head. I'll put it that way. In triangle ABE, right, angle A plus angle AEB plus angle EBA, all of this is equal to 180 degree. Angle sum property of a triangle. So we have this is 90, and if we transpose all of this, we have angle EBA is equal to 180 minus 90, so 90 minus angle A. This is equation 1. Then we have in triangle AFC, angle A plus angle AFC plus angle FCA, which is equal to 180 degree. So this is 90, and if we transpose and all of that, angle A is equal to 90 degree minus angle FCA. Sorry, angle A, not FCA. If we want expression for FCA, so this is angle A. So from one end to what can you tell? Clearly, these two angles have to be equal. Right? Now we'll start off with writing in triangle. And we have angle FCA, which is equal to angle EBA. Right? Both are equal to 90 minus angle A. So this is from equation 1 and 2. See, it looks so neat. Thus by ASA congruency, triangle ABE is congruent to triangle AFC. I hope I'm right, or ACF. Okay, this order is important when you're writing this. And by CPCT we have, therefore by CPCT we have BE, which is equal to FC. BE is equal to FC. Right, that's what we had to prove. Okay, yes, correct, that's it, proved. Okay, so this is how you do. Right, if you write things in organized way, things will be clear. One more thing is, see, the diagram over here, the way I have written, it's obviously not clear, and that's okay. In a sense, it should make sense to me. What we are doing, it should make sense to us. You need not do it in a pencil and pen and all of that. No, I mean pencil and scale. You can do it with a pen and, you know, a rough diagram is good enough. So it should just look similar to what the actual figure is, right? So learn to draw such things, and yes, put it in the middle, it's okay. Only then, you know, your thinking will be clear and things will appear obvious. Right, so now pause and have a look at the answer, and everything has to be copied, including this diagram. Okay, this diagram, not the main diagram that's there in the book itself. So even in exam you need not draw this diagram, that's okay.